And hello, everybody. Thanks for coming on. Thanks for those joining on the web. So my name is Kevin Kawchak. I'm the founder CEO of Chemical Q Device, and this is Thursday, June 27th, 2024. This is discussion 141 for live Python demos with generative artificial intelligence. So basically what we see here is I'm going to go over Hugging Chat. So Hugging Chat is basically another like Chat GPT or Meta AI or Grok or those types of things, GROQ. Then I'm going to go over Blip, and Blip is one of those interesting cases. I actually picked this up from a tutorial. It's an IBM tutorial through edX, and I think it's also on Coursera. So I'll do a line-by-line code on that. And then I'll finish with an agent for coding and then kind of going into UI now. So with this Blip one, it actually pops up a link and then I could share it to my phone. So it's hosting from a Colab. And also with Open Web UI, same kind of thing, but it's actually hosting from my website or from my laptop, this nice laptop I have, this MacBook Pro. And then the link is actually up there. So I have to convert my IP address to a public address with a port number. But anyways, all of the LLMs, this cool generative AI is basically being hosted on this laptop. And I have like 13, 14 models downloaded. So I'll show you how to do that. So the first step here is basically this. So we go to Hugging Face, and we don't want .co, is we actually want chat. And there's two ways of getting to it. It's this. You can also go through the website. So you go huggingface.co, and then this triple bar to Hugging Chat. So they've updated some things. I don't think it was always the case where they had multiple models available, but basically what's shown here is the 70 billion instruct, and I can change that to a bunch of these other ones here. So Cohere for all. It's just the Cohere for all is kind of slow. It's a bigger model. It's over the 70 billion for the Meta Llama. And they have some other smaller ones, this Gemma 27 billion, and Gemma 2 just came out today. And then Llama just had a response to that, something with their compiler as well. So basically, all of these are available, but for like good high quality stuff, we're going to use the 70 billion parameter. And I'm going to ask it about questions regarding Python. So if I go here and I go to explain in detail all of the Hugging Face libraries that use Python, and I hit enter, and it says, what a great question. So a lot of times you get that with Llama, it's pretty positive. And so it says, Hugging Face is a popular open source AI organization that provides a wide range of libraries and tools for NLPs or natural language processing. And the ones that are key are basically, we see transformers, we see data sets. So if you ever use Hugging Face, you're going to use one of those two, at least tokenizers, Model Hub, you'll see Hugging Face Hub. It's a huge thing. The organization themselves, they're still a startup. I think they're somewhere around like Series D, as in dog at this point. But you see all of this, and it's a pretty good response. And it keeps going here too. So you got diffusers. Accelerate, I use a lot for like GPUs. So that's a pip install accelerate there too. So the other ones you see here, so diffusers. So I'm pretty happy with this response as far as what's showing on the screen here. Now I'm going to ask it some more questions. And for those that are just joining, this is called Hugging Chat. So it's actually not .com, it's .co, and they're based all over the world. They're developers. I've seen France, New York. So it's a cool organization. Obviously, I have some models uploaded there, and other people do too. And I'm asking it questions right now regarding Python and Hugging Face. So this is a Python-based coding discussion. And so here's the second question. Explain in detail how exactly Hugging Face Transformers uses Python. So Python as the core language. We see PyTorch, TensorFlow, Pandas, and so we'll have more people kind of filing in here. So we see these, the kind of this incorporation with Python as a core language. And in specific, I was more looking for the transformers using Python, because PyTorch is not transformers, but Pandas and SciPy, NumPy we use all the time. And here we go, transformers, which provides the core functionality for working with transformers-based models. Okay, so again, we're going through Hugging Chat right now, giving it a bunch of questions regarding Python And this other question here is also relevant. So basically, the big organizations use Python. So, to create new applications, when it comes down to like making it run fast, you might switch to C++ or other, C languages. If you have to go into iOS, obviously you'd be using Swift and CoreML. But in this specific case, we're talking about transformers here. So I asked it, explain in detail how exactly Hugging Face datasets uses Python. So again, we usually see with this with Llama 3, like an exclamation. I'm using Llama 3 70 billion on Hugging Chat right now, and there's others to use as well. But this is a good balance between power and inference speed. As you see, it's generating, at a good rate. It's not super fast, but we can definitely read along and then catch up that it finished here too. So those were the three questions to basically, to highlight that Hugging Face uses Python a lot, and anywhere from transformers to data sets to Hugging Face Hub, that a lot of these applications or even pipelines, hopefully we get to pipelines today as we get into more kind of like the hardcore coding as well. Okay, so that's that. And so basically we'll have some questions, and if you have anything at the end, we'll go into that. And then I'm going to split off into the next demo here. So I always keep my Colab linked to show that it's just going to be an open notebook. And then on my end, I'm going to be coding, so line by line, to show you an application. It's called Blip. And I'll give you the acronym in a second here. And basically what this specific one does is it's an easy way, and same with pipelines, Hugging Face has pipelines too. It's an easy way to get started using generative AI, uploading an image and getting some detail with it. So on this specific case, the first things that we need some installs, is we need transformers and we need Gradio. So if you haven't heard about Gradio, it's what's going to allow this basically application, this UI, to pop up on the screen. And before we do that, I actually want to call this. This is the format that I've been using. So Blip Gradio, and then it's using Python, and this is up in the cloud. And then there's no reason to use a GPU in this case. It's not going to help that much. The model's only like 1 gigabyte. If you kept running, maybe. So I'm going to change the runtime. So I'm going to change it to this basically CPU high RAM. It's about twice as fast, and it gives you more RAM. We mostly just want the speed at this point. So it's just a no-brainer, and it's so cheap, and I'm going to connect to it right now. It's basically like 1 penny an hour, or like 1.3 pennies. So their conversion rate is 0.13 of these compute units per hour. So times that by 0.1 is dollars per hour, or $0.013 per hour. So we have that set. And then so the next thing is we're going to have some installs. So the very first thing is going to be, we need pip install, and then transformers, and then Gradio here. And then so typically these are in a different cell. We don't usually include these in other, the main lines of code. And then we're going to install Gradio. So again, Gradio is also Hugging Face as well. So I started off with Hugging Chat, showing you some things with Python. Now we're in a Python environment. I have my high RAM CPU hooked up, and we're going to run this. So I'm going to show this in 2 cells, basically. And for the second one, as that does its thing there, this is going to be the second cell. And this gets us, basically allows us to upload an image or images of our choice. So we're going to import this Gradio as GR, and then from transformers, we're going to import Blip processor. And then the other one, a specific case, is going to be Blip for conditional generation. Okay, so this is, if you've ever used Pill, so Pill was before Pillow, and this is coming from code. I'll show you here. It's from an edX tutorial, and I'll put the notebook up. So if you want to do this on your own, it's a great way to start. And so we're going to use PIL. So this has to do with image processing, and then we're going to import image. Okay, so we need two things. The first one is a processor, and this is going to be equal to Blip processor, and then dot from. And this is where we start getting into the uniqueness of generative AI models. So this specific one is by Salesforce, and it's called Blip image. Let's see, captioning, and then base. And I think that's it for this one. So like if I, and I'll show you this, how this comes up on Hugging Face. So we're going to copy this, and we're going to go to Hugging Face to check out to make sure what we're doing, what we intended to. So the thing with Hugging Face, whenever you paste, just paste, give it a second, and then see if it comes up with the model, and then click OK. So this is what we're dealing with here. So this model, it has close to 1 million downloads, and you can see how old it is by a lot of these. So if it says over a year, I believe that's between 1 and 2, because I've seen others go up to like 5. So it's a semi-recent model. Now, the one that we're going to be using, because we'll be using PyTorch, is these 990 megs of this, specific PyTorch weights. And these are values inside the architecture, and it uses transformer here. It'll show here with this image. And those are the weights for that. And you could read through, and there's a paper on it, and it says like, we use Blip, this new VLP framework for the specific case. So here's the paper that supports it. So when you see models that have a paper, it usually means, there was extra time spent, especially, if it's a bigger organization, if there's more time, GPU training, those types of things. So this is going to be our model, and I'm going to have that open. And now the second thing that we have to do is for model. And both of these are going to use the same Hugging Face model in specific for conditional generation. And then we want from, and then pre-trained. And then it's going to be that again. Okay, so that's basically the Gen AI part of it. And the rest of it is basically setting up with PIL and a couple other functions. So again, I'm still going to do this in 2 cells. The cell above that green check mark, it says that we did okay. And basically, we're going to define this first function as generate this caption. And then this is going to be image. And in this specific case, this is for directly using PIL image object, okay, which PIL is used in other places too. So it's nothing new, but it's this kind of incorporation with the Gen AI model. So we go inputs is equal to processor, and this is going to be images equals image, and then copy return. And here's the PyTorch part. So return tensors, so equals the PT. Okay, so if we look here, it doesn't say PT, but we know this is the format that we use in Python in that specific case. So again, we're using this PyTorch model bin. And if this goes well, it should actually load and say that exact thing, the PyTorch models bin. Okay, so the next thing is outputs is equal to model. And then this is going to be generate, and then star inputs. And then caption, which we're going to have an image that I'm going to upload. So this caption is going to be equal to processor dot decode, and then outputs of let's see, 0, comma, and we don't need this extra part. So we're going to say skip special tokens equals true. So if you're new to generative AI, tokens are basically the Gen AI format of words. So it's a close approximation of if you have like 100 words, you might have 130 tokens, but it's the numerical form of words with that these programs use. Okay, so that's the first function. And then we're going to define the second function, which is this caption image. And this one's image 2. And then we're going to comment some things out, triple quotes. So this takes pill image input and returns a caption. Okay. So this is just a comment here. Okay, so the first thing we're going to do is basically try, and then this is going to be caption equal to generate caption of the image, and then return caption, and then accept exception, and this is going to be as E. Okay, so return, and then this is almost done. So this will get us to about where we need to be at. If this does happen, it's going to say an error occurred. Okay. So basically, string and E. Okay. And this is basically the last part here. So it's called iFace. So iFace. And then here's where Gradio comes in. So the theme of this seminar is going to be UIs. So towards the end, it's going to be a huge UI, my server being the laptop, and I actually got people to kind of run my LLMs by sending them my internet address and that type of stuff. So this one is basically iFace is equal to, and it's just gr.interface. And this fn is equal to caption underscore image. And this is the point, it's easy to miss commas. So basically, inputs is equal to Gradio. So the gr that we need for the UI, and then image, and then type is going to equal to pill. Okay. And then outputs, and this is almost done, it's going to be text, comma, and then title. And this is going to show up in the interface here. So image captioning with a specific blip, with blip, okay? And we'll need comma here too. And basically, and then description, so this will be on the UI too. It'll say equals, and it'll say upload an image to generate a caption. Okay, so that's that. And then the last thing that we need is this. It's called iFace.launch. Okay. So we have our device selected here, and then we're going to hit play, see what happens here. And if you're just joining late, we installed transformers and Gradio, and this is to get a UI of uploading a specific image. So it worked. Okay. So the big things I'll show you here, and we'll pop back to this, is the PyTorch model bin is that. Okay. So this is the Hugging Face page for the model that we're using, this Blip image captioning. So again, if we go back to model card, it'll tell us it's bootstrapping language image pre-training for unified vision language understanding and generation. It's basically a hybrid of certain things, that works. It works okay, but it's not going to work as good as what I'm going to show you at the end. Now, there's two ways of doing this. You've probably seen these types of things before, is I could just do it directly in the notebook. But what I'm going to do instead is I'm going to work off this link. So I'm going to take this, and then so I'm on my computer now. And then I'm going to email this link, and it changes every time that you run that code. So on my end, if I send it to myself, and this is for my phone, then I'll have it for my phone as well. And anybody else, you could use this link too. It's just going to use the resources here off this high RAM CPU up in Colab. Okay, so it doesn't have anything to do with my compute units. That's more like a me thing. It's just saying this, as long as this is up for no more than 72 hours, you should have access to this too. Okay. So the next step is basically doing this is I have, and again, this is Python notebook, and I'm going to give it some Python images. So I'll give it an easy one. So I'll give it something that you might all be used to. Okay. So is there other types of AI that could probably figure this out? Maybe, but it's a good one to start. Okay. So we see the processing up there and it says Python logo. Okay. So that was one. And we'll give it another one. So we click this X and we go here. And then on my end, basically, let's see here. This one's a little bit more complex. It says Python programming, 25 top concepts you should know. And this one, when I've run this before, the output is not going to probably make, okay, this is what it did before. It says Python program. Okay. So you can see it kind of gets stuck. And again, this is a great way to start off your generative AI journey to code. But this is not the most advanced type of Gen AI that we're dealing with here. Now, the last one is going to be another Python. And with this specific one, I think it did a little bit better job. Features of Python language. It actually just got the title there. So there's all different levels of AI to use. So if you're just tuning in, it's a 2-cell notebook that I just transcribed into here. And we use Gradio transformers, Pill, Pill's been around for a while with a Salesforce. So this is the actual Gen AI model. And these things are super easy to get. So, and say like, if we're not happy with this one or we don't like the license, then the licenses shouldn't be, BSD is usually Berkeley software development, which is usually pretty open. But say there's just a different one that we want to use with this notebook too, then we can go to image to text. And then these are other big ones that are image to text. It's not the biggest category. That's typically text generation with like Llama and Mistral. Okay. So that's going to have a bunch of these other options in here too. And again, for a lot of them, we can copy with this copy and then paste into the original notebook and, basically modify this. It could, a lot of times it's the LLM's fault as far as if you're getting good results or not. And that's just a function of changing it, right? It shouldn't be that hard. Now, the other thing is I have my iPhone here. This is iPhone 15 Pro, and I sent that link to myself, and it should show up a little bit on my screen, but basically it's loading right now. I disconnected the Wi-Fi for now because I just want to make sure it's another step to do, UIs and kind of like running models off of different computers on the same network. And it's another step up. So here's the same UI. It's on the phone. I'm on 5G. So I'm going to give it a photo. And, in this case, I'm going to give it, so this kind of drug discovery one. Now, I'm not going to be able on my laptop see what I'm uploading and submitting right now. And it's basically a photo of drug discovery. And it says the diagram shows the steps of drug discovery. So this is an easy way to basically impress those around you that you're using a Colab server, a high RAM CPU. You should be able to stay on at least 8 hours. I know the GPUs are typically around that point, like the good GPUs. Okay. So that's basically what was shown here is I can use image captioning. It's not the best model, but it's something as an intro. And I'll have this notebook up. And again, with some of the links to the tutorial where I found it. So that's it for Blip right now. And where I want to transition is basically if we're not going to use this, well, you can manage sessions too, but basically that's our first one is disconnect. So we're going to disconnect and delete runtime in case you never use Colab. Okay. So we're off Colab. I don't need this anymore. I don't need that. So that link is dead because the server, the Colab high RAM CPU is done. Okay. So this next one is basically, it's a more complex, it's called agent. So basically we're at this third step right here. So for agent, I'm going to open up, it's a LangGraph agent. And basically, if I go to mine and this specific one, So I'm calling this agent executor. And if you're new to the Gen AI world, pretty much everybody that's big in Gen AI, we talk about agents. It's supposed to be kind of like the next big thing. So here's where the notebook is. And on this one, I can make a lot bigger. And we'll just do this too. So we have this agent executor, and here's the link. So it's called LangGraph Examples Agent Executor, and here's the link. And again, I'll have these notebooks up too, so that's good. And before I go through this, because this runs fast, it's one of the faster agent notebooks that I found. We're going to install, LangChain community. LangChain OpenAI is the communication between OpenAI and LangChain. They go together very well. LangChain Hub, LangGraph, and if you're talking about agents, you're very likely going to be talking about LangGraph. So these specific keys, I'll have to reset again. So every week I have to generate new keys. OpenAI key you get from OpenAI, Tavili you get from Tavili, and LangChain for LangSmith is through LangChain, okay? And when I show you here, this is important because it tells my LangSmith, which is what I'm going to open. LangSmith is basically a kind of like more organized, not just a summary, but it actually has all the text of how the software actually works and tries to find certain things using Gen AI. And then, so we're going to use it's GPT 4.0 Tavili. And here's the model, okay? So this model, you see, I'm going to connect to that high RAM CPU. And this, again, is 1.3 pennies an hour. It's really cheap. Now I'm paying, and I'll show you here, it's called through platform. And then we'll also open up LangSmith and then Tavili. So these are the underworkings of this notebook. So you have to have these things in. And basically, on this specific one, so you go to dashboard, you go to usage, and I ran some of these later last night, so they're going to show, okay? So the main things going on is you're paying for the API requests, you're paying for the tokens, like your actual input tokens, and you're paying for the output tokens, i.e. the generated tokens. So this is the one I ran last night, so 27, and we're still in 27 June. And you see, it'll break it down between models, but most of the times I'm running is this GPT 4.0, right? So you see on this bottom one, the breakdown of GPT 4.0, and that's the monthly spend, and then the activity is here. Here's the API requests, or the ones kind of looking like, I don't know why they're not bars, because for a specific day, I don't understand why there would be this extra area. But anyway, we're here at 27 June, and then we're over here, or it's really small, 27 June. And again, this model does not use a lot of tokens. But kind of just take an image, mental image. This is what's going on. If you've never used OpenAI, we're paying for this. So it's $5 per million input tokens. And you saw I was in the hundreds, so not a big deal, and $15. And there's no reason not to use GPT 4.0 at this point. It works tremendous. I use it on, chat with an app. It works really well. So, and that's what we're going to be focusing on is usage with those two tabs. Now, the other one is going to be LangSmith, and we'll come back to LangSmith, and it'll have an update of this agent executor. So I ran this agent executor, and it goes step by step exactly how your generations came up. And it's a form of explainable AI, right? Because it's explaining step by steps. If we don't like the answer, we can run it. It's not on that fundamental level of the software architecture, but it is a form of basically seeing exactly what the software is doing. And then Tavili is basically this, it's a web search. So you just go there and you get a key. And that's all you have to do. And you see, I've only used 62 and I have like 1,000, right? So that's what we're using here. And that's where this information is coming from. And then it's also Harrison Chase's this OpenAI functions agent. And, basically we're going to run this. And there is, if you want to study this more, I would suggest doing that. But what it comes down to is we want this prompt, what is the weather in San Francisco, this history? And then it's going to output agent outcome intermediate steps. Okay, so this is when it was run before. We're connected to the CPU, or this high RAM CPU. There's actually no code that says GPU or NVIDIA or CUDA. All of the processing power is on OpenAI's GPT-4o server. Okay, so at this point, we're installing all of this, and then, like I said, you'll have to get your own keys, because these won't work. But basically, you see agent executor. That's what goes into this. You see agent executor, and to be more specific, it's that specific tab there. That's the one that we're going to be opening. Okay, so these ran, and I tell you, this demo runs really fast. We're not giving it a lot. It's more on the side of like using an agent as an executor. And the tricky part is to use an agent and good results and not take a ton of time or resources. So this actually ran, right, because it was running up here and the installs were the slowest part. So we're going to take a look at the output. And then sometimes for this, it says, I wasn't able to retrieve the current weather. And it's just one of those things with agents. People love them, but they're still developing. And if you want like the most reliable, use RAG, retrieval augmented generation. And in this specific case is 58 and fair. Now in the middle of the day, we're going to check that. So we're going to go to SF weather, and it says it's 64. And it said 58 and fair yesterday. So here's an example, like this ran super fast, but the issue right now is it's supposed to be using this weather underground for today, okay? So that's the issue. And actually, here's that 58 degrees fair in San Francisco, that it's actually in the 60s right now. So if we go over to OpenAI and we're going to refresh this, we'll see the impact of that, everything that we just did. So since it's a small surge, it's just accounting for a fraction of a penny, right? This is another great demo to run. If you're curious about running out of money, I've only spent total $1.35, and I have 120. And when if you spend the $20 on the Chat GPT to get Chat GPT 4o, that is for that. And then the other money is for API requests like this. Okay, so you can see it was really cheap to run it. Unfortunately, our output was not the greatest. And again, we could see the requests here, 27, that it's using this type of filling. So 4 requests, and actually I think 3 of them might have been from yesterday. But as far as cost, because the input was so low, and the output, we didn't get much either. It's really low too. Now, the cool part is the agent executor in LangChain. And we're going to look at today, and here in Pacific right now, it's about 334. So I can immediately rule out all these others except for these 2. Okay. So each of these gives you information. And remember, some of these functions that were created, should continue. Here's the agent, but it's literally step by step. And so what is the weather in SF? That's why this is so low, because context tokens are a combination of the input, the prompt, like what is the weather in SF, and then if there's any other templates that's being used as far as a direction to put the LLM, which you're not seeing, right here. Okay, so that's that. And so usually I at least check this last one too. Now with my website, when I've had to search, in past weeks, it'll actually search like newsletters and stuff, and it'll tell you exactly what it's seeing. But this is basically a lot of that information that's not going to print out necessarily here in the notebook. We do see some of this. So we see Tavily doing some of these things. But in my experience, you also get additional information. So this is called a trace. So that's one trace. And then the other one, this is for Tavily. So this is basically, this is Tavily search results, 58 fair. So like I said, it's a good model to start with. And, so I'll have this notebook up too. a lot of times you'll have to, if you're using Colab environment or whatever, I had to add those, those are the main things. And other than that, LangChain and LangGraph has some really cool demos. I've featured Raptor and some other RAG ones. Those are really cool too. So we're gonna, on this specific one, we're gonna disconnect and delete. And so that'll get rid of our high RAM CPU. Okay, so if you join late, this is OpenAI. You get to it from dashboard. And then if you're concerned about how much money you're spending, go to docs, models, and then here's 4.0. Unless you're doing some very serious stuff, you shouldn't have to use some of these other models. And in fact, this 3.5 turbo is not actually on my, available right now on my ChatGPT. So that's that. We're going to close LangSmith, Tavily, and then we did some San Francisco weather. And now we're going to transition into this really cool part. So for those that are joining late, we're at the Open Web UI. Now, Open Web UI is very synonymous with being a perfect home for Ollama. Now, Ollama, and I'll show you here, we'll go over this, and there's not much to see on the website anyway. It's the very first thing, it should work, is the only one that's in pilot is Windows. I'm at Mac OS, and I've seen other people get it to work with Linux. Again, it should work. It's popular. That shouldn't be an issue. So download Ollama. And there's also, I'll show you for this specific one. This might play right away. It's called Network Chuck. So this is a really good demo. And he was starting to get into, stable diffusion and stuff. But anyways, he used some other OS, and he did virtual Linux. And he got Ollama to work with Open UI or Open Web UI. So definitely you're going to want to watch this video to go through all the steps in terminal to get Open Web UI and Ollama. And Docker, I had to get to work as well with it too. So yes, I did have some challenges with it. But anyways, this is a really good one. You might need some additional help with ChatGPT to fix your specific OS if that's an issue. Okay, so the big news today is basically Gemma 2 got released. And so Gemma 2 is Google's. And if we click here, there's only one thing about it is now it requires Ollama 0.1.47. I have 0.46. So at the end, we'll try to give it a go. But basically, all of these others are just super familiar. Quen, Phi3, Aya. Now, if we look at Ollama 3, which in my opinion, it runs the best, even though it's 8 billion parameters, but it's quantized. So what this means is you have these 8 billion parameters, but the weights are abbreviated. So it's 4-bit instead of 16 float. So all of them, I think, are like that, some version of 4-bit quantized. So the original Llama 3 on Hugging Face, and I'll show you here, which is where they might have pulled this from, is if we type in Llama 3, and it's probably most likely using instruct, is you count the gigabytes. This is basically 5, 10, 15, like 16 gigs. And then over here, we're 4.7, okay? So it fits everything into a much smaller file size. So no, you're not gonna get 100% of the original model, but that's just the way that this will work. And even on this one, I can run the 70 billion one, which is 40 gigabytes. This has 48 gigabytes of RAM. If I don't have Zoom open and everything else is closed. So I'm not going to be able to demo that specific one. But anyways, what you have to do is if you want the 70 billion, you just copy this. And then once you have Ollama installed, is you just put this into the terminal. So again, Ollama is very convenient. It's very up to date. Like I said, with Gemma 2 coming out today, it's already available. And these other models, some are vision. So Lava, I'll feature a little bit there too. And so basically that's Ollama, and then you're going to need to Docker for Open Web UI. Okay, so if you haven't used Docker, that's its own thing too. So there's, a little bit of learning curve to get Open Web UI. Now it's on my port 8080, and I go here. Now on the left is everything that I've run before. And then right here these are all the models. Let's see if I can actually. So you see Moondream, which is the smallest one I could find. It actually, you upload an image, and I got it to work with 3 other people in different parts of the country. So they upload their image from wherever, Midwest, and then it gets sent to this as a server. This PC is still acting as a server to other of my devices. And I process it on my computer with my large language model, and then the answer gets turned back to them. So it's a laptop server. And then we see a variety of these. And again, the only one I'd have issue right now running, as that demo would be the 70 billion. So we're going to start off and we're going to work this up. And basically the first one we're going to do is, and it's easy to forget, is we're going to upload some files. Okay, so we're going to upload 2 files. So one I'm calling drug discovery, the other one's a paper. So let's see there. And on my end, I'll show you through Chrome browser, basically what these are. And this is an equivalent of a RAG, so retrieval augmented generation. And so if I open these 2 in Chrome, I'll show you what's going on. Okay. So here's the first one. It's a Wikipedia of drug discovery. Okay. So it's this 17-page paper. It's not going to be as detailed. Oh, actually, a lot of it is references. So we're going to be searching from this and using the context of these original models to see which does best. We're going to do head-to-head comparisons here. So this is the other one. It's a cell reports or cell press, deep generative molecular design. And basically, we see some really nice images, really detailed. And, it's part review and it's part, emerging stuff. And, basically it's a very complex paper. And, typically probably harder to get into cell press. And we're going to go back over here. And instead of doing just one, we're going to do 3. And to do that, we're going to do 2 phis and a llama. And this first one is going to be the small phi. So this is Microsoft. The second one is going to be this 14 billion. And then the third one is going to be the smaller llama 3. Okay. So it's going to search these sequentially, not at all at the same time. And then on mine, because I'm just doing this, I'm going to keep an eye on the RAM. Typically with heat, Zoom is more of an issue for me with heat, but the models basically just run off of RAM. This is an M3 Max, but anyways, make sure you have enough RAM. If the model says 40 gigabytes and you only have 48, it's going to be tight, right? Especially if you have other stuff open. So this first specific one is going to be here, and it's pulling from the first paper. Okay, so here, so I'm going to give it a question. And how can permeability be determined amongst physicochemical properties associated with drug discovery? And then while this is going, because it's going to take a second, and not always do they all run at the same time. Okay. But this is good for R&D. Like if you have to do the single, and then say if you have to do a single one 10 times and then do the other 2 10 times, like to see what the responses are. So actually what I'm looking for is this Pampa CACO2. That's actually in the paper. And we see with the 14 billion, it ran first, then it ran the 3.8. I'm not quite sure how it determines which is which, but we can look at the speed. So generation info, 20, and it's the top one. It's going to say 27.7 tokens per second, which is going to be slower than the smaller one, which is actually more verbose in this case, which is 53 tokens a second. And then the llama one, difficulty with this is finding this horizontal bar. Say, for instance, here is 48.9. So these 2 middle, the 14 billion and the llama 3, 8 billion ran about the same. Okay. So remember I said the CACO the correct answer is Caco and Pampa. You know, that's the closest context that I could find. And I'm having pretty good luck with that phi3. Basically, if I search for this, you see it says can be determined by Pampo and Caco. So that's a very strong indication that it searched well of these two documents I gave it. So remember here, I gave it those two documents, and it was a question related to the first one. So anyways, I give this winning round to the phi3 14 billion parameter. Now, a cool thing to do with this is you could actually spend some money, or you can, you know, there's other software to do this, but it should be equally effective. I'm going to feed this into some other LLM. So I'm going to ask which of these three produce the best result. Now, the only downside is it won't have the two documents, but I just want to show for proof of concept that it can be done. And in this specific case, I have to say, I have to number these. So for instance, like this left one here, I'm going to copy from phi all the way down. I don't want the two because it's not going to get them anyway. So I'm going to call that my one, and I'll show you what's going on like when I paste this into another cell. So here's my one, and then my two is going to be basically, in this case, the one that worked the best, in my opinion. So again, the downside is it won't have access to the two documents. Actually, I could try. So that's going to be my two. So this will end with potential. And then this is my number three. Okay. So llama. Copy. And I've tried this a couple times, and the only way it worked is when I called these 1, 2, and 3. Because there's other things going on. So basically, which generation 1, 2, and 1 answered the prompt, answered this prompt the best. Okay, that's going to be a question. And so we're going to go back over here. So we're going to actually start a new chat, and we're not going to use phi or llama. So we want to keep this kind of like basically separate from those two. So we're going to use Mistral. So Mistral is approximately the size of the Llama 3. And what I'm going to paste down here is basically, and I'll show you which generation 1, 2, or 3 answered this prompt the best. Okay. So then I labeled 1, and then we'll see 2 and 3. It's just a little hard to scroll here. There's 3 and there's 2. Okay. So we'll give this a go, and I'm going to copy that in case I need that. So then we're going to hit this. So now this is using the Mistral model. They just had a partnership with IBM, and they'll still probably do a lot of open source stuff. So, okay, it says all 3 responses provided, however, the response by 1 is the most comprehensive. So the only other question is that if I upload these files again and see if it can search these with the prompt and the RAG. And these things are, you know, it's not that it can't be done. It's just, will it work in the specific case? And so I'm going to give it that stuff. And I'm going to be more specific this case. Answer the prompt best based on these 2 documents, or I should probably say 2 documents. Okay, so it's going to search those 2 documents, and then we're going to try this again. So again, it liked the first model, the small one, best in the first one, but it didn't really have the context to do that. And it did a good job. So the key thing with this is it's such as Pampa and Kako. So it says, it should say based on both 14 billion and 3, but they approach. Now the purpose of all this is better than an eyeball, right? Because humans, we can miss things if we try to judge which outputs are the best. And, it can be, it's a more kind of like a validated approach to have some other large language model, validate to see which of these approaches was the best. Okay. But it is good that it picked up this Pampa and Kako. And in my opinion, that was directly related to the context of the original question. Okay. So that was that specific one. And then the other ones are basically this is let's see. And there's other questions you can ask. You can ask many other questions regarding those documents, basically. Now we're going to switch over to something fun. So this is basically going to be this model, which I've been sharing with others, and they can communicate or they can run their image on my laptop. So basically we need Moondream and then 2 of these lavas. Okay. So Moondream's the first one. You just keep pushing ++, and then we're going to run a small lava. The lava ones I had issues. If you don't ask about the image, it can tie up resources and maybe even crash. I think that was the case. So we're going to use lava 7 billion, and there should be 13. Okay, so we're going from a really small model, 1.8 to 7 billion to 13 billion. And then what we're going to do on this specific case is use these images from before. And on this case, so this is the really detailed, and I'll show you right here. It's going to be this image right here. So we're going to ask it, and it has the caption in it where it says figure 3. So in this case, you actually don't want to give it too much. If you start giving away things, then it should be finding out on its own. Describe is actually a really hard question for it to do because it's an image and then there's no other way around it. So I'm going to say describe, and it's going to go through these 3. Okay. So we see the image here, and then it's going to be working through those 3. And outputs can vary. This is generative. It's not like internet search. So you can have multiple generations that can vary, like in size and size and quality. So it actually did the Moon Lab was really short, a diagram illustrating the theory framework of the deep genome. Okay, so it picked up some of the text at the bottom. Lava 7 billion, I kind of like because it talks about recurrent neural networks, which is more the essence and variational autoencoders of machine learning. And then Lava 13b. The issue here is it actually didn't. The 13b I didn't like. Well, actually, it says recurrent neural nets and GANs as well. But anyways, it's not always the case that you need the biggest model, and you can adjust the outputs with temperature and tap P and tap K and these types of things. But you see, basically the outputs for the lavas were significantly more detailed, and probably the upper hand going to this lava 13b. Okay. So again, to test all these, if you want to do like massive testing, that would be, find some other large multimodal model that would take this image again and then rank these 3, preferably something bigger than these 3. Okay. So then we're going to check consistency on this one. And I'm going to give it this same thing. So if I go back in here, and so that was the first one. And then here's the second one. And then same thing, describe. So it's going to be processing that. And you always want to check how fast these are working. So as that's going, on this specific one, 33 tokens per second, and then this is 57. Now the upside, the huge upside with this Moon Dream is it's really fast. So it's usually about 130 or 150. I'm not sure. Here it is, 141. So if you can get it to work. Now, the issue that I had was not the model. It was pretty much the internet with the image, because on the computer, everything worked fine once I got other people's images, for fun, these types of things. And, that was that specific one. So, and occasionally we'll give this another shot here. So this would be so sometimes when you move around, it'll cancel the other one. So we'll go to describe. And actually, we got a pretty lengthy response on the first one. Protein structures, A, B, C, D, E. And here's the image that we're looking at there. It smiles graph. So if you do, chemistry, biochemistry, this should look pretty familiar. And, we're definitely seeing more information coming out of the bigger lava models, right? But the point of this and the conclusion of this specific portion is basically, can you make do with a really small model? Because again, over here, if we check 132 tokens per second, and then the slowest one is going to be over here, which is 32. So 4 times faster for the smaller model. But of course, you're not getting the in-depthness of either of these two other ones. Okay, so pretty impressed with the lavas. And again, I use Moon Dream as a proof of concept. And then kind of wrapping things up here, we're going to go into some coding. So if you love to code, you're going to love this section. And I picked 2 of the most recent ones that came out. Now, this DeepSeek Coder, I think just came out within the past month. And then CodeStroll was not too far behind it. So these are kind of 2 big, heavily supported. The first one's by Mistral, and I'm not quite sure the second one. So I'm going to ask it a question, and then we're going to go up on difficulty here. So the first one is going to be this. So again, these are on my computer, and I can verify that if I got rid of the internet right now, I would lose you guys, but I can verify on my computer that they're solely running on my, this is local. So again, this would be like, how ChatGPT or Hugging Face, they have thousands, if not millions of users accessing their servers. This is that on a really small scale, okay? So I say, write a Python Colab notebook that fine-tunes any large language model and pushes it to Hugging Face in a variety of formats, okay? So again, it's called Open Web UI, where I'm using Docker right now to communicate between Open Web UI and Ollama. And I had to use, if anybody's familiar, we could talk about this at the end, it's called Portainer as well. So right now, it went to CodeStroll first. Again, it just runs these, and I see with my RAM, it's like maybe actually, I can read it. 36, and this was gigabytes of RAM. This is with other processes too, and I max out at 48. So I'm still comfortable here. So basically, we look for old stuff, and then we work backwards. All this is still modern, transformers, data sets, and I went through those. Now, in this next part here, when I ran this, so these are looking pretty good. Now, the reason why I say old code is basically I've worked off old models, and I have an MVP, like that's the first thing I did early last year, and it was just not a new model, right? It wasn't based on new platforms and like the leading edge to get your very best report or results and stuff like that. So if I scroll down here, we especially want to find the model. Actually, it says your model here. And my experience with this specific question, we're looking at the right, by the way, and it didn't say, the question had asked I want to save it in 16-bit and 4-bit and GGUF and I have a demo like that. It's by Unsloth. Okay, it's a modern demo. And a lot of times with this type of stuff, it'll give you ideas, but especially fine tuning is not the most pressing thing on people's mind in generative AI. It's more like RAG and, local, on device running and those types of things. So we see more of a general response on the right. This is by CodeStroll. Now, DeepSeek Coder on the left, we take a look at all this. And if it says anything like GPT-2 or GPT tokenizer, we know it's probably some older GPT-2. And for instance, I'll show you. So if we go to Hugging Face, and I know when GPT-2 came out, and all of NVIDIA's or all of OpenAI's model are proprietary except for the old ones. So we see 4 years ago. So again, that's the biggest issue is the model, but it's also like what other code that you're using with it. I can almost guarantee you if you spend a half an hour on GitHub, you could probably find a lot better code. Like notebook, starting points, open source, the whole thing. And I've seen these types and, so they're calling it epochs. I mean, we typically call it steps in Gen AI, but you kind of get an idea of what it is, right? And this is probably, they were fine with this fine-tuned code, and there was probably no other need to really make it much better. Now, I did have a couple other questions or queries for it, or prompts. And I'm going to say, write Python code to generate high quality photorealistic images from a prompt. So we're going to put that in there. And it's going to do its thing. And again, I still haven't figured out which one comes first, but basically the majority of the time they all work. I think the biggest issue is I ran up to 5, sequentially, but it's not, with the scroll bar and that type of stuff. But if that's what you like to do. So in this specific case, I think we're way up there. Here. So this should sound like Stable Diffusion, right? And when I ran this last night, I'm very impressed with the left one so far, and I'll tell you why. So Pipeline is by Hugging Face, and especially if you get started, it's something really easy. Okay, so we're going to see when this was made. So we're going to go to Microsoft Dial Diffusion, and then we're going to go into here. Remember, paste, give it a sec. And actually, that one didn't pop up. And I haven't heard of that model either. But you should really use pipelines, especially if you're getting started. So pipelines is basically like 6 lines of code. And when it said, this is the bulk of it right here. Like there's really not too much else to do. And it's not new, but it'll get you results that are similar to a standard notebook size. If that's the only thing you want is return generated text, So I did say photorealistic images. Now on the right, it's using OpenAI, and trying to see what else is going on here. So, it should work. But again, I wouldn't call the first prompt or the second one awesome. The best thing that came out of it is you learned about Hugging Face pipelines, because it's just so easy to use, but it's not for it's just there's like, I think 25 or 30 different Hugging Face pipelines to do. So then the last one is basically this: write Python code. And this is the tricky one. I want to use either NVIDIA GPUs or Apple Metal. And the one that I got from last night was kind of interesting as far as its response. And what it gave me, and I'm not familiar with this in specific. It's this if CUDA. Well, no, that probably won't work. Else CPU. And I mean, it could work, but usually for Apple Metal, you have to explicitly, state Apple Metal. And so that was CodeStroll. And then this is DeepSeek Coder. So then we'll wait for this. And so basically all of this works well on my own network with the images and doing the smaller models. Now, the issue that I had, with some other people, if they're like on the East Coast or, Central Time Zone, was I think it was more like the transferring of the actual image, because it shows on my end, that the server, performs as it should once it gets it. So we see this one on the left. And Metal isn't too, I mean, it's like, I think it's like within 3 or 4 years, maybe even newer than that. So here's GPT-2, right? So anyways, I wouldn't do that. And I remember when I first started too, and they say, don't trust these things, but it can give you ideas, right? Like, so for pipelines and stuff, but the best code is probably going to be on GitHub and other notebooks, I would say, still at this point, right? So I wouldn't heavily rely on this, especially if you want like a really good starting point that uses today's platforms. I think that's like the correct thing to say there. Okay, so then we're going to do this is basically, I'll show you a little bit about admin. So we go into settings, and then we go into admin settings, actually dashboard. So these are the two accounts that I have. And basically what's showing on my admin is my 8080 locally, okay? And I have access, I'm the admin, to like 14, 15 models, those types of things. And the other one is user. And again, it works good on the laptop and all that kind of stuff. Now, what I'll show you is basically, on my phone here, I have it on, should work. It's on 5G. So I'm going to go to this server's link. So to get to this point, okay. It's not my physical IP. It's the one that the internet sees. And then I had to add the port to Cox, which is my internet. So it's that that visible IP address plus the port number that I approve Cox to open. Okay. So here it is on the phone, so you should be able to see. And the only model, I'll show you another cool thing, is whitelisting. So if I were to allow this access to the 70 billion, this Llama 3, it would just clog things up. It would, number one, I can barely run it myself. And if two of us tried it either wouldn't work or it would just crash. So I only have the small image model, that I can upload an image, and it sends it to the server. So I'm going to do an image, and, just part of me thinks it's probably not as optimized as how if you upload an image to GPT-4o and ask about it, it's probably not that level. So on one of these, I'm going to add, and then the same thing is I'm going to say describe. Now, even though you won't be able to see it too well on my phone here, I'll show you on dashboard, and sometimes it takes us, okay, it worked, here it is on my phone, and here it is here. So I go to chats, and then, okay. So June 27th, it's this one. Okay. So this actually, it's Stanford Medical School. And I just said describe. So, you could probably do more than that, but you wouldn't want to say describe these, medical professionals in their lab coats. You just want it to do the best on its own. So it says the image shows a large group of people, likely medical students or doctors, standing in front of a building. Okay. They are all dressed in white lab coats and appear to be posing for a photo. So far, I think it's true. The group is diverse, with individuals of various ages and genders participating in the gathering. Some of them are wearing ties. Okay. So in previous ones, it said all are wearing ties, but actually some are wearing ties. And as part of their attire, the scene captures a moment where these professionals come together, possibly for an event or ceremony related to their medical studies or careers. They probably wouldn't be in the middle of a semester during finals and stuff like that. Okay. So again, I have access on my phone. It's not connected to this network. It's actually this request went through Verizon, and then it came back through Cox through here, making this an LLM or a generative AI server, right? Or LLM, or in this specific case, it's large multimodal model, LMM. So that's that for that. And I think what we'll do here, because we showed the networking, is that, yeah, I think that we'll do this, is we'll open it up. So if anybody has any questions, and then so we'll, okay, cancel. So you should be able to, let's see here. You should be able to unmute yourselves, I think. And the video should work at least. But I hope that that was very helpful, to go through all these things, because a lot of people could say, like, I know Gen AI, or I know, LLMs, or I know these things. And, that's not always the case, right? Like, you really want to be running and these types of things too. Okay, all right. So yeah, I saw in the question here, the prompt for NVIDIA and Apple hardware said LM. No, so large language models are particularly, the prompt is language, and then the response is going to be language. Now, you can use them for other purposes, and I've seen that too. Now, the other one, LMM, is large multimodal model, and in specific, that's for, like, I just used right now, I sent the Stanford medicine picture from my phone. It ran on this server, and that an image is multimodal. So we're kind of in that transition point, because Apple's going to be doing a lot of stuff on the phone, the iOS, in this fall. They'll be using OpenAI technology as well. And yeah, we're going to be seeing more of it. It's known to probably not be as robust and working as well as, like, the top open source models like Llama or Mistral. There's just more, the picture's typically bigger, in a prompt to send over the internet. And, in processing too, right? So by the time it gets to some server, right, is it going to be, is the generation or the output going to be awesome in quality?
Have there been any differences between the models that you've used in Colab notebooks that you've been able to get access to, larger models, and the smaller models that you're able to run on the local machine? Say, what type of use cases? I mean, it sounds like you're doing image processing. Let's say, what type of, do you keep track of your hit rate? How often a model online is, or let's say a larger model will be more accurate, and how less accurate?
The first thing I think that, like, separates things is the size of the model. So the original Llama 3, which is like an excellent case, it's one of the few that has like really good staying power for open source, because Ollama and so many other platforms, Llama CPP, are based on Llama because it's open enough. So if you have 16 gigabytes, you're not going to be able to run a 16 gigabyte model on an 8 gigabyte phone, and even on a 16 gigabyte iPad. So Ollama kind of standardized all of it to make about all those file sizes about a third. Okay, so at least a third. And so if you have a 16 gigabytes, that's more like 4 or 5 gigabytes, it's on this computer. As far as applications, I've done, protein generations. I've further developed other protein generators, so they were based on, GPT-2, and it's called BERT, right? So, but some of the more original ones, the more earlier ones, and it really just depends on what you're trying to do, right? If you're trying to, I think there's huge value. And by the way, I didn't mention this for troubleshooting. If you're troubleshooting anything, you take a picture, okay, and then you upload it to ChatGPT on your phone, and then it just say, like, I need help with this, whatever in real life you're experiencing, and it can solve. This has happened with me. And if that screen isn't big enough, you go over to your laptop, And that same picture that you submitted to ChatGPT, you go over here, and now you're reading it, and then on a bigger screen, and now you're fixing your real life problem. So there's going to be so many other utilities. I think a good kind of metric is basically with the Apple stuff is, you have an iPad and then you type in like this, or you pencil in with Apple Pencil, complicated math equation, and then Gen AI fixes it. But I see it because there's a trend for going huge in model size. We see this with Grok, which is like XAIs or like Teslas. And then NVIDIA just released one like 340 billion parameters, and that's like terabyte size, like in that kind of area. So the sweet spot is basically finding out what the application is that you want to use the least number of parameters, especially if you want it to run on a phone, like through Swift, like through Apple. And then only use models with the context that you need to solve that issue. Because if you use, say, Llama 3, 8 billion parameters, which is a really good internet expert without getting huge in size, if you're trying to do something in specific for drug discovery, that you don't need all this other information that it learned about just random things on the internet, then you're probably going to have to either make your own model, those types of things. So if you're not at that point yet, as far as doing your, training your own model, I would really suggest to find the really small ones, like Phi-3, the 3.4 billion, that's not too big. And if you want to run on mobile, probably under, 2 gigabytes in size, unless you have a bigger iPad or, nice fancy MacBook. So I would say that it's like keeping the trend right now is with all these models, they want to be internet experts, and then all the benchmarks are based on that. But you're going to have really small models that the weights, like the machine learning weights, you want those to be based majorly on the context of your problem that you're trying to solve for your client, right? So that's the thing. And yes, there'll be many probably unoptimized models that you just use some 70 billion, llama model and then fine tune it with your specific stuff. But if you want it like broad adoption and it runs lightweight and it probably crashes less, those types of things, is you really want to keep the size down and only have weights, for that specific task on that model, not all this other internet expert stuff that you don't really need.
Sure. I have a question about the types of models. Whenever you talk about LMMs or multimodal models versus the LLMs, let's say something like a Claude 3.5 versus a GPT-4o. Let's say, does the multimodality affect its answers in either category? Let's say, like, if you still wanted to do text-based answers, does having it multimodal help it to give better answers, or is it irrelevant?
They're usually behind, so if you want pure language models, if you're only need to use text, so that category in Hugging Face is called text generation. And I think in like notebooks, it's probably like small letters, but like text dash generations. But yeah, typically it's a harder feat to do all of this. A really good example is Gemini. So Gemini is Google's. And if you want access to it, just like, okay, so the ones you mentioned, so Claude Opus 3, ChatGPT 4o, and Gemini, these are all proprietary models. These are not open. Now, Google did release Gemma today, which Gemini uses, but that's still more for the open source community. But yeah, it's typically a harder feat to do more things and to keep the size down, right? So I can't stress enough with model size. So if you search for generative AI notebooks on Google, you'll get their Apache 2.0 Gemini models that you can use. And it has some other, frameworks that I was less familiar with, but anyways, that's an option too. But in general, yeah, that's the hard thing. If you're trying, it's not going to typically, like if you need to input, and this is where you'll hear that term foundation model. If you're trying to move in all of this into your foundation model and get in text and speech and images and videos and stuff like that. There's probably ways of optimizing that, but on a like a per gigabyte basis or whatever of the model, it's going to be a lot more challenging to make everything, work really well. Now, in inferencing, so even if GPT-4o is however big, it's still decently fast. It's not as fast as it's called Grok, GROQ.com. But for instance, like with that type of stuff, is that it, you can kind of get past the model size a little bit, and because it was like an ASIC, like an application specific and chip, and so Grok.com is kind of like still at 300 tokens per second on a 70 billion parameter model. Yeah. So, but as far as it kind of like it sounds like your question is kind of like, is it helping each other like with text, video, speech, and image? That I can't give a definitive answer as far as we have a multimodal. It's just inherently better. My understanding of it is it was more so that you would have to have some of your parameters or weights, attributed to, one type of, like, they're not equivalent, like, right? So they're different types of data types.
Yeah, I was just wondering if it would be better to be specialized in vision or audio processing or text-based generation, or let's see, having a mixture of experts model would help it to encompass all of this versus just uh, you know a single model to to rule them all.
Yeah. Yeah, so I have it downloaded. It's called a Mixtral. It's by Mistral. And so that's available for anybody on Olama, to get up and experiment with. But, I don't think there's a huge advantage of trying to do, and mixture of experts, I think is still text generation. I don't think that's multimodal, like, image, text, those types of things.
Didn't know that. Thanks.
Yeah, any other questions?
I don't want to monopolize all the questions.
Yeah, and I like it. It's good. So, basically, if you missed it, I started with this Hugging Chat, and basically, so Hugging Chat is another, it's a competitor to ChatGPT or Meta.ai, Grok.com. And I think the advantage there, I believe they also have their hands on more so with their own platform. So there's been times where I've had Hugging Face issues and I use Hugging Chat, and that solved the issue where, Meta or GPT didn't, right? So I think you're going to have that case in a lot of times, is that, if they put up a model, I think they're also going to do some fine tuning on their own material. So, to solve their own problems. But basically, Hugging Chat is helpful. If you start off with the original model, it's a little slow. It's called Cohere for All. It's a big model. I would say it's capable, but even when I jump down to the 70 billion Llama model, which I have a hard time running on this, if it's 40 gigs, and I don't know which exact model they're using, if it's quantized or not. But basically, I would switch to something that's a little bit faster, but if you needed help with like pipelines, if you're just getting started, those types of things. And then I talked about Blip, and Blip is a really good example of something that's easy to code. It's that, if you stay for this whole thing, it was basically, I gave it images on Python, and one of them, it got stuck. It said Python something, and it kept, I think it was programming, and it kept saying programming over and over again. So there's limitations to that. And I think there was actually a second Blip as well. But something fun to code. And I focused this agent, which ran super fast today. I asked it the weather in San Francisco. So this is a LangGraph demo, and it gave some responses, but probably not the most up to date on that specific response. Now, I would say, so get to the point where you understand LLMs and you can manipulate them. Some of the key steps to take is fine tune a model, some way to do that. And this is basically inside, say, Llama 3, like 8 billion parameter. There's certain of those parameters that can get fine tuned. And then if you're adding LoRa, like some additional kind of approximated parameters, you can do that too. you should be doing like RAG workflows. There's other agent workflows and Raptor and stuff like that. But obviously the open web UI that I did today, I think a fair number of people get to, but they don't stick with it. Just like do it just to show that they could do it. But it has some power. And I would say, especially locally, like it was hard, right? I spent a good portion of 2 days ago, trying to figure the software out and following that Chuck video. So if you missed it, it'll be earlier in the recording. But basically, I had to use Docker correctly. I had to use, another one, this Portainer. I don't know if you guys have used that. And, so all of this had to come together. And with the help of ChatGPT, actually, ChatGPT 4.0, I was able to get that working. And then hence I had this demo for open web UI. But basically, so this is a very small server, and I'm kind of going to design a new task. And the issue that I had, I think it was more with the image, and it's not quite optimized like, say, the best Android or Apple phone. I don't think it was at that level of sending images back and forth. So, but when it reached here, the tokens per second was like 130 or 150, approximately 150 words per second, but somewhere around there. And it ran well, but it didn't say all kind of like by the time you click enter, people expect to get the image back. But there are delays on ChatGPT 4.0 if you do upload an image too. But I'm just saying they probably have it worked out a little bit fine tuner. And then other than that, I appreciate everybody coming on. So this has been, let's see here. Yeah, discussion 141 for live Python demos. This has been Thursday, June 27th. And for generative AI demos in specific and open web UI. Thanks everybody for coming on, and have a good rest of the night and have a good rest of the week. Take care, everybody. Bye.
Thanks.